This is Unit 2, Chapter 4, Lesson 5, Adding and Subtracting Mixed Numbers. Here's Mr. Romanovich.
Hey, we are going to add and subtract mixed numbers, like Mrs. Benoit said. Get your title down, make sure you get your video down so you know exactly what those notes apply to. Then here's our target today. It's a little bit more in detail than usual. I can convert mixed numbers to improper fractions. That's what we want you to do. Get those mixed numbers into improper fractions and then add or subtract them. And by the end of this video, you should be able to solve these two problems plus one mystery problem at the end. Feel free to find one funny face that I made and the entire time pause it and take your notes down. Let's go. Mixed numbers to improper fractions or vice versa. Let's look at that. We know mixed numbers are numbers in which we have a whole number and a fraction attached to it. Then improper fractions are when our numerator is larger than our denominator. So we have something that's more than one but just in fraction form only. So to do that, I put two negative numbers up here. What I want you to do is just take the negative and kind of put it off to the side for a minute and then do the calculation, then just put the negative back on at the end. So when you look at this, you're aware of this. We're going to multiply here and we're going to add here. So 7 times 2 is 14 plus 4 is 18. And we maintain our same denominator. So we have 18 sevenths. And let's bring that negative over now and call it negative 18 sevenths. And just like Mrs. Perdue said, make sure you're applying that sign only. You can't leave yet. Only in the numerator. Keep your signs in the numerator, leave your denominators just plain old plain. So negative 2 and 4 sevenths becomes negative 18 sevenths with the negative on the numerator. Negative 19 thirds, once again, don't worry about the negative at first. Figure out how many wholes you can get out of 19. We know it takes 3 pieces to get a whole, so 19 divided by 3 would be 6. So 19 divided by 3 is 6, leaving us 1 remaining. And then that remainder becomes our leftover piece. We have 1 more third to account for. That's why our denominator doesn't change. And then don't forget then to bring that negative sign over here and apply it again. So we have negative 6 1/3. Okay. Let's get some examples. 5 4/5 minus 1 3/10. So here we go. First thing we're going to do, convert them to improper fractions. So 5 times 5 is 25, plus 4 is 29, and that's still over fifths, minus 10 times 1 is 10, plus 3 is 13, 13 tenths. And now we know if we want to dance, we've got to have the same denominator. We got to turn them into like fractions. So I'm going to have to do a little side math here. If I look at this, I know that 5 and 10 have a common factor, or a common multiple. It's 10. So we're going to multiply this side by 2, top and bottom, times 2, times 2, so that I end up with 1 denominator of 10. 29 times 2, here's my side math, 18, 1, 58. Which gives me 58. I bring my operator down here, minus. Then I bring my other numerator, 13. And then I look at that and I say to myself, 58 minus 13. I can do that, or I could add the opposite and say 58 plus negative 13. They are interchangeable. 58 minus 13, though, is 45. That is my horrible 5 over 10. Now, you have one choice here, and one choice only. You have to simplify. So this needs to be in simplest form, but for us, we're going to allow you to keep it as an improper, or you can convert it to a mixed number. Either one is fine. But for right now, this specifically, this improper, would not be right. It needs to be in simplest form. They both have a common factor of 5, so if we divide both by 5, we get 9 halves. Which is correct. And we would also accept 4 1/2, because those are equivalent. So either one of these would be successful. Let's look at the second example. 7 minus 1/2, and I know a third of you are saying to yourself, you can't do that. That's silly talk. Well, you can. All we have to do is make sure we get common denominators. That's the key here. So we're going to convert this 7 into a fraction. Let's make it an improper fraction, 7 over 1. And we're going to subtract that from this improper fraction. We multiply here and add there. 2 times 1 plus 1 is 3/2. Now I know that I'm not going to be able to get this 2 into a 1 because that'll make a complex number on this side, and we have not done that yet. That doesn't come until unit 6. So right now what I want to do is I want to convert then this one to halves. And to do that, I know 1 times 2 is 2. 7 times 2 is 14, which gives me 14/2 minus 3/2. Then I set up my dance floor. And that's over 2. 14. Bring my operator over, minus 3. Or you could add the opposite, 14 plus a negative 3. In fact, I'll even write it like that. 14 plus a negative 3 over 2. What you'll see is we're going to get the same answer either way. 14 minus 3 is 11 over 2. 14 plus negative 3 is 11 over 2. Is that in simplest form? Yes. If you wanted to switch it to a mixed number, you absolutely can. How many 2's will fit into 11? 11 divided by 2, a little side math. 5, 10, 1 remaining, that's fine. So I know that I'm going to have 5 and 1/2. That remainder becomes my new numerator. My numerator does not change. And this would also be 5 and 1/2. Either way is fine. Let's do one more. I'll do it fast, don't worry. Here we go. Find the perimeter of this shape. So perimeter is the sum of the sides together. So you're measuring the length of the fence around this yard. Let me put some green grass in it. I don't have a green marker. Okay. If I don't have a green marker, you know what it is? It's not a backyard, it's a pool. We're making it a pool. I don't have a green marker, so we'll just make it a pool. How far around the pool can you not run? So if we're doing perimeter, we're going to add the sides together. And what I would do first is I'd make sure, and I learned this from Mrs. Purdue, is I want to put the terms that are similar, I'm going to put those together. I'm using the commutative property, the communicable property, something like that. So all right, we're going to take 1 and 1/3 plus 1 and 1/3 plus, and I'll make this a different color because it has a different denominator, 2 and 3/5. All right? So I got 1 and 1/3 and I've got 1 and 1/3. I can kind of put those together already, right? 1 and 1/3 and 1 and 1/3, that's got to be 2 and 2/3 plus 2 and 3/5. So now we switch them to impropers. 3 times 2 plus 2 is, I'm getting down to the bottom here, let's scoot this over a little. 3 times 2 plus 2 is 8/3. 5 times 2 plus 3 is 13/5. We're adding these together. Let's get a common denominator. When I look at 3 and 5, the lazy 7th grade student in me just says, just multiply by the other one. All right, I'll do that. So I'll multiply by 5 here, and I'll multiply by 5 here, and I'll multiply by 3 here, and I'll multiply by 3 here. And you are all done with those calculations in your head. So I have 40 over 15 plus 39 over 15. Set up my dance floor, and just like you do, I'm going to keep writing smaller and smaller and not get a new piece of paper. And then I have 40 plus 39 over 15. Then, all right, fine, I'll move it over a little, and I'll erase the black line. I'll put a new black line, because this is what you would do too. Which equals 79/15. 79/15, do those have a common factor? I got 3 and 5 and 15. I don't think 15 goes into that. 3 won't go into that because it doesn't add up to, the sum of the digits is not divisible by 3. 5 doesn't go into that just because it doesn't end in a 5 or a 0. So how's the time on this? This is going really long, isn't it?
Yeah, you're almost at 10.
10? Oh, I got to get in before 10. All right, so here we go. So that's improper, and at that point there's no way to reduce it or simplify it. So I can leave it like this, or if I want, if you're more comfortable with this, you can convert it to a mixed number, which is probably 6. 6 times 15 is 90. That's too much. So it's got to be 5. So 5, I'm going to continue my arrow. 5 times 15 is 75. I just know that. Over 4/15, that's what's remaining. 79 minus 79 minus 75 is 4. There's my remainder. There's my thinger. There's a thinger. And then I got to put the units. And the units are feet. 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 So we have a teeny little pool. It's it's probably plastic. Okay. Can you hit the target? We've got 5 1/4 minus 1 3/10. We've got 16 minus 5 5/6. And then here, this triangle, which you can imagine as either yard or pool. It's equilateral too, because all the sides are the same. Find the perimeter of that. Okay? Good luck. If you have any questions, you can ask me, you can ask Mrs. Benoit, you can ask Mrs. Perdue. She's upstairs. Or you can check your book, or you can rewatch this video. Or whatever. Good luck.